All right, so in the last video, we talked about proof for the angle sum of a triangle being 180 degrees. Now, this thing that we've established is very useful because this gives us an insight into the angle sums of a number of different polygons. Now, polygons are essentially just closed 2D shapes. So ones we may be familiar with, our hexagons, pentagons, any types of quadrilaterals, essentially any straight line closed shape. So let's have a look here, right? So we have our triangle here. So I've just written this note from the last lesson. I'm going to draw another triangle. So this one here, I've drawn. Now, what if I were to extend this into a second and add a second triangle to this one shape? So let me go like this and like this. What we have here is a quadrilateral. So this is, quadrilateral. Sorry, I think I'm lagging a little bit, but a quadrilateral is a four-sided shape. It's a type of four-sided polygon. Now, these come in various forms. These come in the form of squares, rectangles, trapeziums, rhombuses, parallelograms, etc. Right? And we can go into all of those, but the main core thing I want to look at is the quadrilateral. A lot of them, and well, not a lot of them, all of them can be composed of two triangles. They can be made out of two triangles. So let's have a look here. We have 1, 2, and we know that each of these is 180 degrees in size. Hence, this tells us how much the angle sum of a quadrilateral would be, right? It's essentially 180 degrees make up this space as well as this space. So altogether, we have that it is 360 for the angle sum of our quadrilaterals. So quadrilateral angle sum is 360 degrees. And we can test this with a bunch of different ones. I'm just gonna insert a couple of shapes here just to show you. So let's go with our square. So a square is comprised, once again, of two triangles, drawing from one corner to the other. Same with a rectangle. So let's extend this. So just drawing from one end, one corner to the other without lines crossing. So we can't, also do this because we're essentially looking at one side to the other. This is that's how we kind of compose these shapes out of our triangles. So same with a rectangle. We see here to here, two triangles. I'll draw a trapezium as well down here just to really drive this point home. Once again, we have one triangle and we have another one here. We have composed our quadrilaterals of two triangles. Now, okay, that's cool. That works out as well. Let's start looking at angle sums of a bunch of different polygons, shapes that we're comfortable with, and let's see if we can pick up on any patterns here. So let's try, for example, a hexagon here. hexagon. All right, let me draw one. Apologies in advance if my drawings suck, but I'll do my best and hopefully you'll be able to get the picture. All right. Now, our hexagon, a six-sided shape. This hexagon, well, let's see how many triangles we can make, kind of extending from this one vertex here. We have one, we have two, we have three, and an extra one left. Once again, we have four triangles here. We have 1, 2, 3, 4. All of which, once again, have an angle sum of 180 degrees, 180 degrees, 180 degrees, and last but not least, 180 degrees. Now, what's the total sum here? Adding all of these together, we get 720 degrees. So I'm going to write here, hexagon angle sum is 720 degrees. Now, one more. I'll give you one more just to drive this point home, and it should help you. We're going to try to come up with a general formula for determining the amount of, well, the angle sum of a polygon. So I'll give you one more, and we'll see if we can consolidate this all together into a general rule. I'm going to give you an octagon here. Oh god, this drawing's going to be bad. Bear with me, please. 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, good enough. All right. Once again, let's make some of these triangles here. It's maybe a little squished, but we have 1, we have 2, we have 3, 4, 5, and 6. So 1, 2, 3, 4, 5, 6 triangles located in this octagon, and all of their sums are, well, all of their angle sums are 180, because the angle sum of a triangle is 180. So we have 6 here. So this angle sum is 6 lots of 180. And to save you the calculation, I'm just going to give it to you because that's not the point. The calculation is just there. But we actually want to look at what's happening here. So I'm going to zoom out, and you tell me what you have a think about, I should say, what you observe here. So give you a moment, pause the video if you need, but I'm going to get into it now. We observe a pattern with all of these shapes, which is that based on their number of sides, there are always 2 less triangles we can fit into the shape. So you can see I'll get rid of this so you can see, our quadrilateral had 4 sides and we made 2 triangles. Our hexagon had 6 sides, we made 4 triangles. And our octagon had 8 sides, we made 6 triangles here. Now, this is a pattern we observed going all the way through, and I urge you, draw some massive sided shapes and do the same thing, and we will get this pattern where the angle sum of our polygon, and I'm gonna consolidate this all here. So we have the angle sum of a polygon is, so I'm gonna write this general form and one that you probably would have concluded as well to find these. So we have that n minus 2, with n being the number of sides of the polygon, multiplied by 180 degrees. This is our general formula we got from building these shapes with our respective triangles. And I'm going to put a box around this. So, our quadrilateral, hexagon, octagon all followed these patterns. And you'll find that bigger shapes and some of these shapes in the middle, feel free to try it with a pentagon or any others. Honestly, play around with it because that's the best way to learn. But the general formula for finding the angle sum of a polygon is n minus 2, which the n is, and I'm going to make a note here actually, the number of, the number of sides, n minus 2, which n is the number of sides of our shape, multiplied by 180 degrees. Because the amount of triangles we make in there is always 2 less than the number of sides of the shape. Hence this n minus 2. That whole n minus 2 is just the number of triangles. So that's a little handy way to calculate these angle sums of really big shapes. I'll see you guys next time. And that, I think for now, rounds off our angle geometry portion.